Welcome to DSA classes. So where exactly we will be discussing about the entire DSA data structures and algorithms end to end. So which you are able to get it in a regular course which you pay and which you get it. We are doing all this in our YouTube things. So where we do it on lecture basis. So maybe like in a week 2 classes or in a week 1 class. In this way we will be doing it. So today's agenda, while we are going with the DSA, is like what are data structures. You can see our today's agenda. What are data structures, what are algorithms, examples of algorithms, and discrete math which is required for in order to write any algorithms in lines of your programming. What are the discrete math required, and why to learn our DSA, data structures and algorithm, and a simple code breakdown in order to understand algorithms and even in order to understand our array data structures and even our stacked data structures. So this is our entire plan of our today's agenda. So before getting into this agenda, let's understand about first thing. So why we need to have, or why we need to learn anything like DSA. So why we need to learn it. So why we need to learn DSA, data structures and algorithms. So in order to understand it, let's go with two things. So every computer program, if you take Facebook, which is constructed on top of computer programming. If you take Swiggy, where we place orders related to our food every day, where we use it with respect to the programming. And not only that, if you go back to Amazon, where exactly you place bunch of orders related to the dresses or related to the products or groceries or some personal grooming things and all this, where exactly you will be, which the Amazon is constructed on top of programming. Or we all go to the Instagram and we browse a lot of time, which is constructed on top of programming. So the YouTube, which you are playing the videos, which you are listening this DSA classes, which is done on top of programming. So whenever we are writing a computer program, so the computer program is ruled by two things. So every time, or we can say computer program is ruled by two things. So one is your time and another one is your memory. So one is your time and another one is the memory. So how much, so whatever the computer program you are writing, how much memory it is taking, that is first challenge. And the second challenge is how much time it is able to execute a particular computer program. So every time in order to execute a computer program, there is again the math behind the computer program. So the time required, or in order to run any computer program, what is the amount of time, or how exactly we can calculate the amount of time is number of lines written or number of instructions written. So you are writing, for example, 100 lines of instructions to your computer program in order to view a particular video in YouTube. So what is the time required in order to view a particular video in a YouTube is number of instructions written in order to view a YouTube video and multiplied by time taken to run each instruction. So now how we can calculate the time, for a computer program is, in order to, for example, let's take a simple example. I just want to watch a YouTube video. So this is your YouTube video. I just want to watch YouTube video. So in order to watch a YouTube video, what you will be doing, you directly open YouTube, you just click on it. It's hardly takes 1 or 2 seconds in order to watch a video. So but whenever you are looking on to the computer program, how we can define the time required in order to execute a computer program is how many lines of code someone has written in order to view a YouTube video and multiplied by time taken for each instruction we have written. For example, some instructions are taking a huge amount of time. Just imagine there is a very weak programmer or there is a very poor programmer, so where he has written a YouTube and in order to watch YouTube video it is taking 10 minutes, means in order to just click on a YouTube video it is buffering, or in order to click on it is not even loading. We all face this kind of situations with YouTube or even with Facebook or even with some applications as well. Why isn't sometimes the Facebook may not able to respond, or your Instagram is unable to respond, or your YouTube is unable to respond, respond. Why? So because of maybe because of a huge amount of lines, or maybe because of some issues, so your some of your programs may not be able to execute. And just imagine, by the sake of great programmers, so we just need to thank them. Why? In the sense, because of them we can just, without any time consuming, even though our net is so good, if your website is taking a lot of time, what we can do, the example is IRCTC. We all are familiar with the railway sites, or we are aware of the government site, which take a lot of time in order to load it. Why? So now we don't use this concept of optimizing the time or optimizing the memory. So why we want our data structures and algorithm people, why we want this great programmers, are for the same thing, in order to reduce the time taken in order to execute an instruction. So why, in the sense, if a time is taken for each and every instruction, so it overall increases the time to execute one particular program. And not only that, number of instructions. So even every time the programmer need to work towards reducing the number of instructions we are giving it to a particular thing to do, or a particular task to perform, we always need to think towards, is there any possibility to reduce the number of instructions? And not only that, for example, in lines of learning as well. So if you are taking how exactly the time taken in order to get your job is dependent on the complexity of the course you have chosen and the number of topics you are learning. The more topics you are learning, it actually taking more time in order to get a job, and multiplied by how much time you are taking in order to learn each topic. In the similar way, even in order to complete a task, means like a program, so it is depends on number of instructions a programmer is written, which is multiplied by how much time each instruction is written. So shall we do this? Shall we remove all the instructions so that we no need to give any time, everything going to run in a so good way? We can't do that. That's the reason. So we got the purpose of DSA. So why we are knocking the door of DSA is data structures and algorithms. Why you need to perform DSA, data structures and algorithms, is in order to optimize your code, in order to reduce the time. So now I just want to run a complex thing. For example, let's take Facebook. So Facebook comprises of millions and billions of users in Facebook. So whenever a person is using Facebook, or millions of people at a time using Facebook, if they are trying to watch a video, if whenever a person is giving a comment, or whenever he is interested to post some story, or whenever he is interested to post some status, so the Facebook should not take a huge amount of time in order to load it, or in order to perform a task. We need to do it as quickly as possible at a fraction of seconds. So that is very important. In order to do all this, so the programmers are struggling what we can do. That's where they knock the door of DSA, data structures and algorithms. So what exactly the purpose of data structures is? Data structures is called as storing and even accessing your data. So whatever the data you created, you need to be in a position to access it, and you need to be in a position to update it. Just imagine you have your phone. In your phone, there are a lot of contacts in your phone. Or let's take your WhatsApp itself. In your WhatsApp, there is a huge amount of chats which you've done with all your friends. And all the chats which you communicated with your friends are something very important for you. You need to access the chats every day in a frequency. Like every day you want to access the chats. Even the chat of 2017 need to be accessed today. So it's very difficult to do that. So in order to do that, what you will be doing, so you want something to access and to update it. So it need to have an easy access. Whenever you want, you just need to go to that and you want to do it. Just imagine in your phone, you have a lot of images, and in order to access the image which you shot it in 2014, if it is taking a huge amount of time, it is a pain area you have it in order to view your old images within your phone. So every time whenever we are storing the data, the purpose of storing the data is not just only about storing it and keeping aside, but we need to access them and we need to update them based on the requirement. So I'm a user in Facebook where I created my account in 2014, let's imagine, or I created my account in 2012. So I just want to see the post somewhere I have written, or I'm logging into Facebook after a few years. So the Facebook is unable to pull out my information. It is unable to access where this Kant is. Why? I created my account in FAR 2012. So I did need to update my profile. It is taking a lot of time. So in order to handle all these issues, what we do, we take up the concept of data structures. What is the purpose of data structures is, in order to access the information, how well you are arranging the information, why you are arranging the information in a proper way in order to access them and in order to update them at a very less amount of time. For that reason, you are knocking the door of your data structures. So in your data structures, you have two different types of your data structures. One is called as linear data structures. So one, we call it as linear data structures, and another one we call it as non-linear data structures. So whenever you are going for a linear data structure, some of the examples of linear data structures are like array data structures or stack data structures or queue data structures or linked list. All this comes into your linear data structures. And what are your non-linear data structures? Are anything which is coming under your trees, or anything coming into your hierarchical, or we can say like maps, and all this comes into your non-linear data structures. So in a linear data structure, the data is stored in a linear way, and whenever you are going into a non-linear data structure, the data is not stored in a linear way, it is stored at multiple levels. So we call it as your non-linear data structures. And the name itself, the linear data structure itself is saying, Kant, you are saying linear and non-linear. In a linear, you are arranging the data in a sequential way or in a linear way, and whenever you are getting into non-linear, you are arranging the data in a hierarchical way like a trees. For example, you are arranging the data in lines of a hierarchy, linear, or non-linear, or you are arranging the data in lines of a sequential, which is a linear data structure. If you are arranging your data in a hierarchical way or a tree kind of way, we call it as non-linear. And if you are arranging the data in a sequential way, we call it as a linear data structure. And based on the name itself, so in order to execute a linear data structure, if you are able to execute with a single entry, or if you are able to run it for single time, the entire data structure going to be executed in linear. And whenever you go to non-linear data structure, in order to execute entire line, it may not be possible. Means in order to execute the entire data structure, it may not be possible. It takes multiple entries or multiple runs. Why? So there are different levels or different hierarchical positions to execute each and every point. That's the reason it demands multiple runs in order to execute this non-linear data structure. And in order to execute your linear data structure, a single run is sufficient. And again, one more difference we are able to see from linear to non-linear is, so the time complexity increases for your linear data structure. As your data structure size is increasing, the time complexity increases for your linear data structure. And when it comes to non-linear, the time complexity remains same irrespective of the size increasing. If the size is increasing, so even though the size is increasing, the time complexity may not increase. So it remains the same. That is one of the benefit with a non-linear. Then you can ask me, Kant, when the time complexity is increasing for a linear, why to use linear data structure? We can only use non-linear data structures, right? What is the use of using non-linear data structure? What is the use of using linear data structures? So based on the use case, based on the I will be showcasing one use case. Based on the use case or based on the task which you need to perform, you need to choose between a linear data structures or a non-linear data structures. So irrespective of the time, so we try towards optimizing the time as well, so within the same linear data structures and a non-linear data structures. So again, one more thing. So in lines of every computer program, one of the very important thing is scalability. So we discussed about two things. One is time, another one is the memory. And within the time of a particular computer program is purely dependent upon the the number of instructions written and the time taken for each instruction. And when it is coming to your computer program, one more thing is important, which is called as scalability. So the very simple example of a scalability is, now you can use any small website. You can take any small website. For example, in a website, I'm hardly getting somewhere around 10 people per day. So now the computer program, in order to execute 10 people per day, it is taking within seconds you are able to get it. Take the Facebook. On the very first day the Facebook is founded, only few people, maybe hundreds of people or maybe thousands of people may be using Facebook. So it is responding so good and it is doing so good. So after a couple of months the users are increased to lakhs, and after a few days the users are expanded to 10 lakhs or crores or billions. In this way the users are keep on increasing. So even though the users are increasing, so even though the burden on the particular site is increasing, so the time to execute everything is remaining same, means so now your program is having the concept of scalability. So you, whatever the program you are writing as a programmer, so it need to have a scalability as one of the primary characteristics. So whatever the program you are using, you should not keep on updating it. For example, this code which I have written is only for 1000 people, the code which I have written this only for 10,000, so this code is for only 10,000 or 1 lakh. So it should not be like that where exactly you keep on updating it. So the one program which you are writing, which is okay even if the scalability is increasing, even the huge amount of data is falling, so the time to execute this is same as running it for 1000 people or even for 10 people or even for 1 people. So the time is remaining same. So the scalability is one of the very important feature when you are writing your computer program. So for that reason, so you have types of data structures like linear or non-linear. So the linear disadvantage, as the time is as the data is increasing, so the time complexity, what happens, so the time increases in order to execute it. But when it comes to non-linear, there is no much challenge with respect to the time on top of your data increase. So that's what we are able to notice between linear data structures over non-linear data structures. So before going into what is stacking, what is array data structures and all that, so before discussing about them, so we can discuss about algorithms. That is something we are pretty much having a doubt. So let us discuss about. You are able to see one syntax here on my screen. You are able to see a small syntax which is related to algorithms. So here, whenever we are going to this algorithms, this is called as one algorithm. So the purpose of this algorithm is in order to identify the highest number or the largest number. So in order to identify the largest number, you can see over my screen, I have written the first line. What exactly we are doing at this first line is I'm defining an input operation. This entire code is written on top of Python. We can write the similar things in Java or C, whichever is comfortable for you. Now this is something I'm showcasing it on Python. Now I'm giving it as a user input. Instead of writing this line, what is that? So the data which we are giving it as an input need to be float. And we are giving this command input. So by giving this input command, what exactly it's going to do is I'm saying enter first number. It can be anything. It can be enter first number. It can be first number, or it can be you're writing only first and number. Whatever the way you want to write it, you can write it down. So it is indicating it for a customer. For example, I'm using it whenever I'm executing this code, whenever I say enter first number, so I'm entering like 10. So the value which I'm entering 10, what need to be the data type? It need to be the float value. Or I'm entering the second number, what need to be, you can see here the output. So whenever I execute this syntax, first it is giving me enter first number, so I'm entering 10. After that it is asking enter second number, so I'm entering 40. And after that third number, again it's going to say enter third number, again I'm entering 20. So now what exactly, I'm writing a logic. So first 3 lines are only giving us the help in order to input the data. So I'm inputting 10, I'm inputting 40, I'm inputting 20. So how exactly this particular 3 lines, how my Python is able to understand which one is the largest? My Python don't have this intelligence. So now I need to write down an algorithm. I need to write down an algorithm in order to identify the highest or the largest number. So what is an algorithm? Algorithm is nothing but the series of tasks or the series of commands or the instructions you provided for a program in order to do a specific task. So in a very simple note, what is an algorithm? The series of instructions you provided for a computer program in order to achieve a specific task, we call it as an algorithm. Now, what exactly the instructions I passed? If number 1 is greater than or equal to number 2. Means in this case 10, is it greater than or equal to number 2? Yes. And number 1, is it greater than or equal to number 3? So largest equal to number 1. So in the first case, so number 1, is it greater than or number 2? Not exactly, it is false. And when it comes to again second condition, number 1, is it greater than or equal to number 3? So 10, is it greater than 20? Not exactly. So the largest is 1. Is it 1? Is it right? No, it is a wrong statement. This is failed. So once this line is filled, what I need to do, there need to be else condition. That's where I used else if. So number 2, is it greater than number 1? Yes, the number 2 is greater than number 1. That's right. And number 2, is it greater than number 3? Yes, 40 is greater than 20 as well, and 40 is greater than 1 as well. So then based on that, what I need to do, you need to say number 2 is the largest. So it no need to check for the last condition. Why? Already the second condition is true, so it is not checking the final condition called as else. So then once you are able to identify the condition, what you need to do, print the largest number is this. The largest you have it, so in the largest what you have, number 2. So you are printing that number 2, 40 as the largest number. That's what you got it as your output. So now we call this as an algorithm. So what is an algorithm? The series of instructions you passed it to a computer program in order to achieve a specific task. We call it as computer program. So we call it as an algorithm. So in order to achieve that task, in order to design this algorithm, I'm using conditional programming or conditional statements. So if statement, elif, else, all this comes into conditional statements. So we are using conditional statements in order to achieve the task by using this particular algorithm. What is the algorithm name? Identifying the largest of 3 numbers is the algorithm which I have written. So algorithm is simply a series of instructions which you pass to a computer program to achieve a task. We call it as your algorithm. So in order to write down these algorithms, you have multiple means like you basically use any programming language like Python or all. So Python or Java or whatever it is, based on the task or based on the task which you need to achieve it. But in order to write computer programs or algorithms, you need to have some basic idea about your some of the mathematical topics. We call it as discrete mathematics. Now here I'm trying to understand a logic. If you see here, I'm trying to understand a logic. What is the logic? So out of 3 numbers, which one is highest? In order to do that, I will be using from the discrete mathematics logic. And for example, if you want to identify, I'm giving an year like 2022 or 2024 or 2023 or 2019. So it need to identify whether the year is a leap year or not. So you need to use your number theory. And or exactly Kant, I'm watching the videos or I'm learning data structures and algorithms or I'm learning BTech or I'm doing this branch or that branch. What are the chances of getting a job? So you will be using from discrete mathematics probabilities. So or Kant, I need to identify the shortest way in order to get a job. Or Kant, for example, even if you look back to your Google Maps or if you go back to your Ola and all that, it always identify the shortest route in order to reach it. Every time even we do the shortest route to do some task. In order to understand the shortest route, we want graph theory from your discrete mathematics. And next thing is, for example, now you are getting a salary or you are paying, you are taken your let's take the salary itself. Now you are trying to get you're working for 5 years in an organization. So what going to be your salary after 5 years? If your salary is growing at a rate of 25% per year, recurrence. So in order to understand the recurrence, for example, it can be used in the salary or it can be used, you want to invest on a particular thing, what need to be the amount of money you will be getting after 5 years or after 10 years or after 2 years, after a month of 2 months. So what is the amount of percentage you are able to get it? What is the compound interest you are getting? To understand all this, you need to know the recurrency from again discrete mathematics. And the sixth thing is counting. So how many different candidates they test for their interview drive. For example, now I want to hire 10 people. In order to hire 10 people, we got 10,000 people. In order to get the actual 10 people, so out of 10,000 people which I'm doing conducting an interview drive, so how many candidates I need to test it? So I can't actually interview all the 10,000 people. I need to interview only few people so that I got the best 10 candidates. You need to know the discrete mathematics, the concept of counting. So by taking the help of this discrete mathematics, and you try to write all this discrete mathematics in lines of your program, the suitable program, using your Python or using your Java or using your C, and you try to encrypt on top of your websites or the things which you constructed, so that your websites, it can be Swiggy or it can be Facebook, they are able to achieve a task, they are able to perform a task based on series of instructions which you provided. So this is where the purpose of algorithms are used. And whenever you are writing this algorithm, so whenever you are doing this algorithm, one of the very important thing is like whatever the data you create or whatever the things you have it, they need to, so the entire program need to have consume the less amount of time, it need to take a less amount of memory, and even every algorithm which you are written need to have a scalability that is very, very important. So the next thing is, let's have a look over your one of the data structure. We call it as a stacked data structure, or I'm not going into array or stacked all this. So just I want to give a small example for this data structure. What is a stacked data structure? So stacked data structure, before going into this stacked, you need to understand a basic terminology. So in a stacked data structure, the name stack itself means you are piling the things one after the another. So where you are able to see the things piling one after the another, so you can take an example like your notifications which you are getting. Let's imagine you are getting a notification. So let me, for example, you are using your mobile phone. So the time today is like, let's imagine you can see 12:29. You got a notification from Gmail. So this is going to be in your first position. So after 12:29, the time is 12:30. So you got another notification from Instagram. So again, your time notification, so on and so forth. Your time notification is 4 p.m. in the evening. Again, you got a notification from something Naukri, or you got a notification from LinkedIn stating that you got some notification. Now, the notification which you got on Gmail, you haven't checked your phone from afternoon 12:30 or 12:29 till evening 4. Now, when you just opened your phone, the first notification you're able to see is your Naukri. So once you completed, so what is this? This is your last notification, and this is your first notification which you got it. So you are unable to check your phone from 12:28. So the first notification you got after 12:28 is from the Gmail, but you are unable to check the Gmail first. So you will be checking the last one. So what exactly you are doing? The last one, you are sending it as your first out. So now you got your Naukri as the last one. So what you are doing, you are just clicking on that particular Naukri and you clear it. In this way, in order to go to your Gmail, the first one going to be viewed in the last time. So that is called as your stacking. So all your notifications in your phone are in a way of your sequence, or in a format of your stacking. So now in the similar way, now not only with the notification, so it can be in lines of the products you are adding on top of your cart. Maybe it is also in the format of your stacking format, each and everything going to be added. So the notifications which you are getting, again in the format of stacking position. So the history which you are able to see in your YouTube history, or it can be your Gmail history, or it can be your Google Chrome history, whatever the history you are able to see, again it is in the format of the stacking. The first thing which you viewed, it go back to the last, and the last thing which you viewed going to come into the first. So which is in the format of the stacking. So now the stacking your data structures, is it an example of a linear data structures? So stacking is a concept of your linear data structures. So in a linear data structures, and when you are getting into stacking, there are two different terminologies. One is push, another one is pull. So what exactly meant by push and what exactly meant by pull, or let us get into this. Now when we are getting into push and pull, now push is used after 4 p.m. I'm getting another notification at 4:05, so which is from something like Facebook. I'm making it as Facebook. So now in order to add the new elements, or in order to pile the new elements, you need to use a push command. So now you already viewed your Naukri and you just want to see it. You already completed the notification of Naukri. Then you need to push, or you need to pop this notification. We need to pop this notification. So I already saw this. So this notification is not required no longer. So I need to send it outside. So the push is sending in the notification. So pop is like sending out the notification. So once you viewed it, what I need to do? I need to send it outside, pop. So I need to view a notification. A new notification came in, push. So for example, when you go back to your history, the very first thing I am watching it, push. So the new thing which you are searching, I'm searching about data structures, push. For example, I don't want someone to see this history. So pop means I'm sending it outside. So the push command is used in order to stack up or to pile up your notifications, or to pile up the data, or to stack up the data, you use push. In order to send the data outside, you use the pop command. And there is one more called as isEmpty. So what is the purpose of isEmpty is whether this data structure is having any elements or not. In order to check it, we will be using one more called as isEmpty. So isEmpty is used in order to check whether my data structure is it filled or is it an empty. In order to understand it, I can use isEmpty. So now you can see this. I created a small stacked data structure. So in order to do that, I defined create underscore stack. It can be any name. It can be, I gave my name as create underscore stack. And the stack, we all know, if the empty square braces are called as you are defining an empty list. And if anyone is using create underscore stack, we need to return the stack value. So we need to return the list. So after that, what I'm doing, I'm defining empty list. So how exactly I'm checking the empty stack? So check underscore empty. Again, I'm defining a user defined command. So I'm defining a user defined command, check whether it is empty or not. What need to be empty? The stack which you created. Is it empty or not? So when this stack going to be empty? When the length of the stack is equal to 0. So when the length going to be 0, when there are no elements within that stack, it going to be 0. If there are multiple elements, it going to be 1, or it going to be 2, or it going to be 3. So there are no elements at all. So the stack, it is saying it as 0. If it is 0, then what you need to print? You need to say the stack is empty. The logic is defined here. And again, in order to add the elements, now I created an empty stack. I created a normal create stack where there are no elements at all. Now I need to add the elements, means I need to add the data into it. In order to add the data into it, what I'm doing, I'm creating another user defined command called as push. So push stack, comma, what you need to add within this into the stack, you need to add the items. So I'm saying stack.append of item. So you know the command of append. In order to add each element at a time, you will be using append command. Again, you have append and extend commands in lines of your list. So in order to add each element at a time, we use append. So we are adding elements into it. And once we added an element, what we need to do, or an item we added, pushed item is this. We need to print it. And removing an element. So every time in a stack operations, there is adding an element, there is a removing an element. So in order to remove an element, you are using a command called as pop. Check if the check underscore empty stack, return stack is empty. In case if your stack is empty, you are checking the command. So when your stack is empty, you can't use sending the elements out. It's a useless command. That's the reason before you are using pop. So I'm checking whether my stack is empty or not. If it is empty, no need to run a pop. In case if it is not empty, then you need to run your stack.pop. That's what I have done. So you can see stack create underscore stack. I'm just after defining it, I'm storing it into a variable called as stack, and I'm storing new string called as you got a message from Kant. And another element I'm adding, another notification, someone liked your profile pic from Instagram, or you received an email, another notification, I passed it. You left something on your cart, I placed an order in some Amazon, so, and I'm unable to pay the money, so I just left it and I went back because of some emergency. So you've left something on your cart, you can check it. So now print popped item. So pop.stack. When I'm saying, so now you can see here, so whenever I'm executing all this push command, the item is pushed. You got message from Kant. So next thing is, again, another element I pushed it, someone liked your profile pic. You received an email. You left something on your cart. So now whenever I use pop command, here I used pop command. Whenever I used pop command, so you left something on cart, this is what it sent it first out. So now you got first message, that is first message which you received. Second received is this. Third received is this. Fourth received is this. So this is your last notification which you received, or we can say the fresh notification which you received. So in order to view it, what I will be doing before watching, you got a message or liked your profile pic or you received an email, first I will be just viewing something left or you left something on your cart. So this is what I'm sending outside. So this is pop. So once I send this outside, the next thing which I send is like you received email. The next thing which I send is profile pic. And the last thing I send is your message from Kant. So the first one going to be sent the last out, and the last one going to be sent the first out. So that is the concept of your stack operation. So this is a very simple Python command. You can just take this code, you can test it on your Python, you are able to see so how these things are working. So this is called as a stacked data structure. So we came to know about two things. So the purpose of DSA, what exactly the purpose of hiring a DSA guy is, like they need to work on data structures in order to store the data in such a way that it is optimizing my time, it is reducing my memory, and it is helping me to achieve my what we can say, in order to increase or in order to achieve the scalability. And we are using algorithms in order to achieve a specific task or in order to do a specific task, and we are feeding those sequence of instruction to the computer program. And in order to write the algorithms, you need to have a knowledge about your discrete mathematics. So we discussed about multiple discrete mathematical concepts like logic, like number theory, like graph theory, like probabilities, like recurrences, like your what else, like I missed something. So in this way we discussed about multiple discrete mathematics which are important in lines of going with your algorithm designing. So these are the things which we discussed. So on our next lecture on our DSA, we discuss even more on what is means we will be taking some separate topics. We discuss on some of the terminologies on data structures and algorithms. So now today I just gave a view why to learn data structures or why data structures is. As a simple note, as a simple start, I gave this theory. On the next we will be starting from the some more basics which we need to discuss, like pointers and divide and conquer theorems and all this we have it. We will be discussing about this basics so that you will be getting into the proper alignment with the DSA. So thank you so much. In case if you like this content, please do subscribe to my YouTube channel. Thank you so much.